Welcome once again, bizarre creatures enthusiasts. As we embark on a meticulous, comprehensive biological investigation into the sophisticated neurological and optical mechanisms prevalent within the planet's most dynamic, specialized, and visually complex ecosystems, the shallow marine seabeds, our subject today is the cuttlefish cepeda, a stunning, highly intelligent cephalopod whose very existence in the dense, high-visibility, diverse benthic environment is predicated on extreme cryptic coloration and cognitive uniqueness. The cuttlefish presents an unparalleled masterclass in evolutionary lineage, employing a combination of chromatophore control, specialized W-shaped pupils, and 3 separate hearts, cementing its status as the supreme master of disguise and one of the ocean's smartest invertebrates. The foundational element of their survival strategy is the alarming morphology of their circulatory system, which is not merely an oxygen distribution tool but an intricately engineered sensory and metabolic device, allowing rapid changes in blood pressure and color. Chemically speaking, the musculature controlling the chromatophores allows extraordinary expansion and manipulation, enabling the cuttlefish to perform a crucial predatory function, notably creating mesmerizing, hypnotic waves of color to disorient and paralyze small prey. The critical level of hunting behavior. The cuttlefish exerts its effect by binding optical input with motor output, using its specialized, complex eyes to read the environment and its skin to broadcast patterns simultaneously. This binding event is catastrophic for the specialized, often small crustacean prey because the animal is able to consume it without fatal consequence, completely overriding the prey's sophisticated defense and escape mechanism. The resulting continuous, rapid pattern generation allows the cuttlefish to access food resources that are too fast or inaccessible to almost all other major marine ambush predators, causing persistent and forced exploitation of the shallow reef niche. This overwhelming, highly focused hunting strategy rapidly leads to severe central nervous system disruption for the prey, resulting in immediate systemic paralysis, followed inevitably by catastrophic, unsynchronized ingestion by the specialized cephalopod. The historical context of this morphology is critical. The unique, complex structure of the cuttlefish eye, despite its lack of color receptors, remained largely unknown to the Western scientific world until modern optics, primarily due to its rapid adaptation and the complex, inaccessible nature of its endemic habitat. Their method involves a deliberate, non-lethal, yet highly efficient probing of the sand and rock, allowing the precise collection of high-nutrient crustaceans, a perfect example of sustained ecological utility through cognitive innovation. The most profound biological enigma surrounds the animal's blood. Despite its visual distinctiveness, the blood is based on a specialized, copper-based protein hemocyanin that gives it a blue-green color, preventing the catastrophic collapse of oxygen transport in low-temperature marine environments. This specific anatomical specialization within their circulatory system essentially renders their entire physiological system chemically resistant to chance, preventing the fatal energy expenditure that affects every other generalized marine fish. Crucially, the cuttlefish does not engage in extensive herding. It operates purely as an ecological anchor, systematically utilizing micro-reservoirs of high-nutrient prey to fuel the massive metabolic demand of its specialized, brain-focused ecological research has definitively linked the cuttlefish's social structure to the prevalence of specific visual signals, primarily marked by specialized color patterns on their skin, which function as communication depots in the absence of vocal cues. This highly specific circulatory system implies that the ultimate oxygen carriers likely originate in the unique copper found in seawater, are then processed by the specialized gills, and finally concentrated by the 3 hearts. A triple-layered physiological dependence. This highly specific behavioral structure implies that the Ultimate warning signals likely originate in the unique optical receptors of the eye and are finally concentrated by the rapid skin patterns, a triple-layered neurological dependence. The cuttlefish has evolved specialized, densely packed pigment sacs distributed across the entire body, which function exclusively as secure, permanent communication depots for mating and specialized protection against the nightly deep-sea darkness. The cuttlefish has evolved specialized, densely packed, layered reflectors distributed across the dorsal surface, which functions exclusively as secure, permanent structural coloration and specialized protection against the nightly deep-sea darkness upon even minor mechanical stress or perceived threat. These animals instantaneously utilize their siphon and specialized skin for propulsion and defense, creating a rapidly effective, ready-made sensory mantle that deters any potential intrusion attempt. This critical observation provides irrefutable evidence that the cuttlefish's powerful survival is an environmentally determined phenotype, inextricably linked to the unique, complex optical composition of the shallow marine environment. The loss of its specialized reef habitat and the introduction of ocean pollution and habitat destruction presents a dire, dual existential threat. Not only is the animal losing its physical home, but it is simultaneously losing the entire visual support structure essential for its specialized camouflage mechanism. The incredible diversity across the Cepeda genus shows a profound singularity. The cuttlefish's 3 hearts and blue blood are a unique physiological trait, a fact which reflects the precise, localized metabolic specialization of this particular species. Beyond the aggressive hunting, the cuttlefish exhibits surprising degrees of obligate parental care, with the female vigilantly guarding her eggs against desiccation and pathogenic fungal infection for weeks after the eggs are laid. The dedicated mother undertakes the arduous, dangerous task of constant vigilance, navigating the environment to locate isolated, predator-free micro-reservoirs of high-quality food. In certain individuals, the animal exhibits an extraordinary level of camouflaging skill, changing color constantly while it hunts, only pausing briefly to consume its prey, a behavior known as blending. This high investment in offspring survival, contrasting with the animal's solitary, intimidating presence, beautifully illustrates the profound and often paradoxical evolutionary pressures at play in complex, high-mortality environments. The specialized color-changing skin and chromatophore control itself remains a cornerstone in modern biomimetics, providing a perfectly calibrated, highly selective probe for studying the kinetics and structure of specialized camouflage technology in human military systems. By meticulously studying the skin patterns and neurological analysis, scientists aim to design specific display systems or novel synthetic tools that could revolutionize the detection of underwater objects and environmental changes. By meticulously studying the cuttlefish's specialized hemoglobin and chemical composition, scientists aim to design specialized oxygen-carrying fluids or novel, synthetic systems that could revolutionize human blood substitutes. The visual arsenal of the cuttlefish's skin collectively represents a vastly unexplored behavioral reservoir, holding untapped potential for developing new classes of biomimetic systems focusing on display, technology, and low-light communication. The evolutionary phenomenon is further confirmed by the discovery of similar specialized camouflage techniques in unrelated species, like certain chameleons and flatfish, reinforcing the concept of a shared behavioral and ecological defense strategy. Their unparalleled combination of extreme bizarreness, profound specialization, and specialized ecological dependence solidifies their status as one of the most enigmatic and scientifically crucial organisms on Earth. This intense scientific breakdown should leave no doubt that the most bizarre, visually shocking inhabitants of our planet frequently wield the most powerful, meticulously engineered, and deeply mysterious biological secrets. Now, we turn the focus back to you, our dedicated audience. Following this deep exploration, which other creature possessing extreme, bizarre, or unique skeletal or behavioral properties should bizarre creatures investigate next? Please share your suggestions for future topics, along with any specific questions you have regarding the cuttlefish's 3 hearts or its specialized camouflage system in the comments section below. We value your critical engagement. If you found this granular, scientific dissection of the cuttlefish and its ecology informative and stimulating to your curiosity, please take a moment to hit that like button to significantly support our specialized content production. Ensure you are permanently subscribed to the Bizarre Creatures channel today for continuous weekly updates and in-depth scientific narratives on the world's most incredible and often misunderstood animals. Critically, remember to activate the notification bell, guaranteeing that you are immediately alerted the moment our next exploration into the profound mysteries of the natural world is released. Thank you for joining us for this highly detailed session of Bizarre Creatures. Stay intensely curious, and we will continue the relentless pursuit of the world's most shocking biological truths together.